Hi students, this is Shekhar sir. Today I will explain about Kirchhoff laws. Okay, it is important for 10th class as well as it is important for JEE Mains class 12 students. Okay, now let us start here. So Kirchhoff laws. So what is the Kirchhoff laws? Okay, now there are two laws are there. Kirchhoff laws. First thing is a junction law. What does mean junction law? Junction law we can call as a current law. Junction law or we can call as a Kirchhoff current law. Kirchhoff current law. So once we have to look at the statements. The sum of the currents flowing into the junction is equal to the sum of the currents leaving out of the junction. So coming equal to leaving. So here, for example, here the current coming towards the junction here I1 is coming this direction. Here I2 is a current coming in this direction. They are meeting at a point. This point is a P. P is a junction point. Here some currents are leaving out of the junction. Some currents are leaving out of the junction. So here we can take another other example also. Here we can take as I1, I2, I3. Here it is a I4. Here it is a I5. Here it is a I6. So what is the Kirchhoff's junction law says that sigma, it says that sigma I equal to 0. So the sum of the currents at the junction equal to 0. It says that the current coming towards the junction equal to the currents leaving out of the junction. So వచ్చే current లో junction వైపు వచ్చే current లో equal to the junction నుంచి బయటకు వెళ్ళే currents కి equal అవుతుంది. It says that there is no charge. It says that there is no accumulated charge on the junction. So it says that we cannot create a charge in the junction or we cannot destroy a charge at the junction. So here it is. What are the currents coming towards the junction? Here the currents coming towards the junction we take as a positive. So here I1 is a positive. I1 plus I2 plus I5 which is equal to the leaving out of the junction. Here minus I1 plus I2 plus I5 minus here what is there? I6 plus I3 plus I4. Okay, now coming towards the junction we taken as a positive, leaving out of the junction we taken as a negative. So here when we write here equation becomes I1 plus I2 plus I5 equal to the I6 plus I3 plus I4. I4. This is the okay. The current coming towards the junction equal to the currents leaving the junction. The currents leaving the junction. This is the okay. The junction law. Junction law. What is the use of a junction law? Junction law. By using junction law, we can find the unknown current in a given circuits. Unknown current in a given circuits. Okay. Now junction law says that the sum of the algebraic sum of the currents at the junction equal to 0. The sigma I says that the algebraic sum currents at the junction equal to 0. Okay, now and the total current at the point junction equal to 0. So the currents coming towards the junction we taken as a positive. The sum of the currents coming towards the junction equal to the sum of the currents leaving out of the junction. So by using this junction law, we can find the unknown current in the given circuit. So for example here they are given that here it is a 5 amperes, here it is a 7 amperes, here it is a 3 amperes. Next they have given that here it is a 2 amperes, here it is a 4 amperes. 4 amperes. Find the I3 current. Find the I3 current in the given circuit. So we have to apply the Kirchhoff laws here. So the current coming toward the junction. So what is the current coming toward the junction? Simply in this direction. So this is the 5 is coming. 5 plus 7 plus coming towards, we taken as a 3 equal to the 2 plus leaving out of the junction 4 plus here it is a I3. Okay, now we have to find the I3. So 5 plus here it is a 15 equal to, directly I will write 15 minus 6 equal to I3. So here I3 equal to 9 amperes. I3 equal to 9 amperes. So by this way, we can find the unknown currents in a given circuit by using the Kirchhoff's junction law. Or junction law, or we can also call as a loop law. Loop law and junction law and same. Okay, now once again look at the statement. The sum of the currents coming toward the junction equal to the sum of the currents leaving out of the junction. Coming equal to leaving out of the junction. So this is the, it says that the sum of the algebraic sum of the currents at the junction equal to 0. So this is the about Kirchhoff's junction law or Kirchhoff's current law. Next thing is Kirchhoff's voltage law. Kirchhoff's voltage law is very important. Okay, now Kirchhoff's voltage law is used to find the unknown resistors in a given circuit, in a complicated circuit. Okay, now it is useful in network analysis. Kirchhoff junction law is Kirchhoff old loops law is used in power grids. It is used in Wheatstone bridge to calculate the unknown resistance or unknown currents in a given circuit. We have to use the Kirchhoff's loops law. What is the Kirchhoff's junction law? Kirchhoff's first law is called law of conservation of charge. Okay, Kirchhoff's first junction law is also called law of conservation of charge. Law of conservation of charge. Law of conservation of charge. So it says that we cannot create a charge, we cannot destroy a charge in the circuit. Okay, so ఒక circuit లో charge ని మనం create చేయలేము, charge ని destroy చేయలేము. It is a law of conservation of charge. Total charge remains constant in the circuit. Circuit లో total charge ఏముంటుంది అంటే constant అనేది ఉంటుంది. This is the junction law. Next thing is a loop law. Second law is a loop law. Kirchhoff's second law is the loop law. Loop law, or we can call it as a voltage law. Loop law is also called as a voltage law. Here, current loop law is based on the law of conservation of energy. Energy means, law of conservation of energy means we cannot create a energy or we cannot destroy energy in the circuit. Okay, now the total charge, the total energy remains constant in the circuit. Okay, now what does mean voltage law? Okay, now voltage law means the algebraic sum of the potential difference. The algebraic sum of the potential difference across any loop in a circuit. Okay, now across any loop in a circuit is equal to 0. Okay, now the algebraic sum of the potential difference in a closed loop must be equal to 0. This is a loop law, or simply we can write it as a in terms of potential difference and EMF. Okay, now sigma IR plus sigma equal to 0. Sigma IR plus sigma equal to 0. Okay, now the total energy is remains constant in a given circuit. Okay, now sigma V equal to 0. Okay, now for example here I will explain simple circuit here. Here I taken as a battery. Here potential difference I taken as a V. Here I applied a resistor. Here is a R. R is a resistor. This is a circuit. We have to apply the Kirchhoff laws to the circuit. Okay, now the current is flowing this direction. I current is flowing in this direction. This is the resistor. Here it is a circuit. We have to apply the Kirchhoff loop law. Okay, now to understand Kirchhoff loop law, first we have to understand the sign convention. So here, what is the sign convention rules? What is the sign convention rules? Sign convention rules. For example here, battery is there. Okay, now for example here, battery or cell is there, EMF is there, battery is there. When we move from positive terminal to the negative terminal of the battery. So when we move from lower potential to higher potential, when you move from positive terminal to the negative terminal, higher potential to the lower potential, so EMF of the battery we taken as a negative. EMF of the battery we taken as a negative. That is the one rule, sign convention. When we move from battery positive terminal to the negative terminal, EMF of the battery is we have to take it as a negative. We have to take it as a negative. Next, when we move from this is a positive terminal, this is a positive terminal, this is a negative terminal. When we move from negative terminal to the positive terminal, we have to take it as a EMF of the battery. We must take it as a plus. When we move from negative terminal to the positive terminal, EMF of the battery we have to take it as a plus. Positive we must take it as a positive we have this call. When we move from lower potential to the higher potential, EMF of the battery we must take it as a positive. When we move from higher potential to lower potential, EMF of the battery we have to take it as a negative. Next thing is when it comes to the potential difference. So here it is a potential difference. The current is flowing in this direction. Okay, now when we move along the direction of the current, when we move along the direction of the current, then the potential difference is taken as a negative, minus IR, minus IR. Potential difference is equal to minus IR. When we move along the direction opposite to the direction of the current, then the potential difference we have to take as a positive. We have to take when we move from here against to the direction of the current, potential difference we have to take as a positive. We have to take as a positive. This is the sign convention rules we have to use when we are solving the when we are solving the loops law problems. First law is the sign convention is important. For example, when we move from positive to negative, so higher potential నుంచి lower potential కి వచ్చేటప్పుడు we have to take the battery EMF as a negative. When we move from lower potential to higher potential, battery EMF we taken as a positive. Next, when we move along the direction of the current, potential difference we taken as a negative. When we move opposite to the direction of the current, potential difference we have to take as a positive. Next thing is here it is a small loop law is there. We have to apply the sign net loop law equations in this diagram. So the current is flowing in this direction. We have to take we can take loop law in this direction. So in this direction I am applying the loop law. So I am moving from A to B. So I am moving from the positive terminal to the negative terminal of the battery. So here loop law, here I am moving from positive terminal to the negative terminal of the battery. So here positive to the negative, in this direction I am moving. So here EMF of the battery taken as a negative. EMF of the battery taken as a negative. Simply here I taken as a R1. Here I taken as a R2. I taken as a R2. So here it is I am moving. Current is moving in this direction. The current is flowing in this direction. I am moving against to the direction of the current. So here it is a minus V plus I R1. Next here also I am moving against to the direction of the current. So here plus I R2 equal to 0. So this is a net potential difference at the loop ABCD. So here the total increasing and decreasing potential energy in a closed loop must be equal to 0. It is a loop law. So here it is a potential difference across the battery when I am moving from ABCD direction. It is a negative. Next, but here it is a potential difference is a positive. Here also it is a positive. So it is says that net the algebraic sum of the potential difference in a closed loop equal to 0. అంటే the increasing and decreasing potential difference in a loop must be equal to the 0. Okay na, increasing potential energy, increasing potential difference, decreasing potential difference in a closed loop equal to 0. Okay na, this is the loop law, or this is the this is the voltage law. Next, this is the one circuit. Next thing is I will explain to a bigger circuit. Here I will give a example to a how to write loops equations to a bigger circuit. So we have to use the sign convention when we apply the loop law numerical question. From when we move from positive terminal of the battery to the negative terminal, higher potential to the lower potential, battery EMF we have to take as a negative. When you move from negative terminal to the positive terminal, battery EMF we have to take as a positive. Okay, now here I will give the bigger, okay, now difficult, complicated circuit. For example, here it is a V1 is there. Here it is a resistor R1. Here it is a resistor R2. Here is R1, R2. Here battery EMF I taken as a, here it is a V2. This is a I taken as a R3. Look at here, this is a V1, the battery EMF V1. Here it is a potential difference V1. Here it is a V2. Next I1. Here it is I2. So here we know that the current is flowing, always flows from positive terminal to the negative terminal. So I1 is current moving in this direction. Okay. Now next I2 current also here moving in this direction. So here it is here it will be I1 plus I2. The current will be I1 plus I2. So the current is flowing in this direction in a given circuit. The current is flowing in this direction. Okay, now next here in this case we have to apply the loop law. Here it is I taken as a point A. Here I taken as a point B. Here it is a point C. Here it is a point D, E. Here it is a F. Here it is a F. So we can apply loop law in any direction. For example, in this direction, first I apply the loop law in this direction. So for the loop A B C D, A B C D a loop, we have to apply the loop law equation for the A B C D a loop. So I am moving from A to B. In this direction I am moving. So I am moving from battery higher potential to lower potential. So we have to taken as a negative V1. Next, opposite to the direction of the current. So here we have to take it as a I1. Here we have to take it as I1 R1. Next, here we are moving along the direction of the current. Along the direction of the current here. So it will become I2 R2. So look at here. This is the when we move from lower potential of the battery to the higher potential. So it will be V2 equal to 0. V2 equal to 0. This is the net potential energy is at a loop A, B, C, D. Net potential difference at a loop A, B, C, D. So here it is the potential at the point A to B, potential difference at this here it is a negative. But here it is a positive. Here it is also positive, here also positive. But total is a 0. Total is a 0. So the algebraic increasing and decreasing potential difference in a closed loop equal to 0. So there is no loss of energy. The total energy remains constant in the given circuit. Next we can apply the loop law to the circuit. We can take any direction. For example, here I am applying the loop law for the DCEF. DCEF. So in this direction, I am moving in this direction. Simply we can take any direction. Okay now. So I am moving from D to E. So along the direction of the current. So here potential drop equal to minus I1 plus I2 into R3. I1 plus I2 into R3. This is also along the direction of the current. So here minus along the direction of here it will be the minus I2 R2. Sorry. So here it is a minus I2 R2. Next here it is we are moving from lower potential to the higher potential, negative terminal to the positive terminal. So we have to take it as a plus V2 equal to 0. Plus V2 equal to 0. This is the loop law for the loop equation for the this loop. Okay, now by this way we have to write the loop equations for the complicated circuit to find the unknown current in the given circuit. Here I will give one numerical question. We have to solve the numerical question. We have to find the current. Here 8 ohms voltage is there. Here is the 1 volt. Next here I have taken as a 2 volt. Here it is a 1.5. Resistance is a 1.5. Here resistance is a 9 ohms. Here resistance is a 9 ohms. In this circuit, we have to find the current I1 and I2. Find the current I1 and I2. Okay, itla diagram based question ichi find the current I1 and I2 in the given circuit antaru. So here battery, here potential difference is 8 volts, here it is a 12 volts. Next thing here it is a potential resistance is a 1.5 ohms. Here resistance is a 1 ohm. Here resistance is a 9 ohms. So we have to apply the loop equation for the loop A, B, C, D, A. Apply here. We are moving from higher potential to lower potential. So minus higher potential, lower potential minus 8. Next opposite to the direction of the current. So plus I1 into resistance how much is there? 1 ohm. I1 into 1. Next along the direction of the current. So current is moving this direction. We are also moving in this direction. So potential drop is the negative. So minus I2 1.5. Next here we are moving from lower potential to higher potential. So here it is a plus. Here we have to take plus 12 equal to 0. Plus 12 equal to 0. Solve here. When we solve here, I1 equal to 1.5 I2 plus 4. 1.5 I2 minus 4. I1 equal to 1.5 I2 minus 4. This is the equation 1 we can take. This is the equation 1 we can take. Next we can apply the loop law for this equation. For this equation we have to apply. So we have to take as a loop D, E, F, C, D. We have to take as a loop. Here it is a D, E, F, C, D. We are moving along the direction of the current. So we have to take as a negative. So here minus I1 plus I2 into 9. So we are in this case also we are moving same direction. Same direction we are moving. So minus 1.5 into I2, or we can write minus I2 into 1.5. I2 into 1.5 plus 12. Lower potential to higher potential we have to take another 12, which is equal to the 0. This is the second equation. So here multiply here. When you multiply here, minus I9 I1 minus 9 I2 minus I2 1.5 I2 plus 12 equal to 0. This is the equation 1. This is the equation 2. Now put the value of, put the value of I1 in equation 2. I1 in equation 2. So when we put the I1 in the equation 2, we will get the I2 value. Put here minus 9 into what is there here? 1.5 I2, 1.5 I2 minus 4 minus I2 here minus 1.5 minus 1.5 I2 plus 12 equal to 0. Multiply here minus 9 into 1.5 which is equal to minus 13.5 I2 minus 36 minus 36. Next thing is here, sorry, now minus into minus plus. Okay, now plus 36 minus here 9 I2 plus 1.5 I2 minus 1.5 I2 plus 12 equal to 0. Plus 12 equal to 0. So when we add this here, minus 24 I2 equal to minus 48. When the minus get cancelled here I2 equal to 48 by 24 which is equal to 2 amperes current. Which is equal to I2 equal to 2 amperes current. When you put in the equation 1, when you put the value of here, you will get I1 equal to minus 1 ampere. Minus 1 ampere. This is the how to find the unknown currents in a loop by using the loop law. By using the Kirchhoff's voltage law or loop law, we can find the unknown currents in a given circuit. We have to find the unknown currents in a given circuit. Okay, now this is a circuit. Okay, now first we have to apply the loop law to the any loop. V A B C D A, or we can apply A D C B A. It's our choice. Once, okay, now please pause the video. Once again you can understand. Once again you can listen my explanation. Okay, now please like this video, share to your friends, subscribe it. Thank you.